One of the big challenges with robot picking applications is obviously variation in light, environmental factors, etc., different clips. And what's built into this system that's really smart is that it self-learns. So welcome to another Machine Monday. So we recently developed a very interesting system using AI to support robot picking applications. And in this case, what we did was we created a model that would identify the orientation of a clip and send those coordinates to the robot, and then the robot would then pick up the clips accordingly. But one of the big challenges with robot picking applications is obviously variation in light, environmental factors, etc., different clips. And what's built into this system that's really smart is that it self-learns. So after 2 days of data, a new model is created. After 4 days of data, a new model is created. After a week of data, a new model is created. And what we found is that after 7 days of running the system and self-learning that's built in, the system was basically 100% reliable, so much so that we switched off all the lights in the factory, let the machine run just with the lights in the station, and it picked up clips 100%.
Sorry for this interruption, but I thought it might make sense to give a bit more detailed overview of the system architecture of the solution I'm presenting in this Machine Monday. But I thought many of you may be interested in knowing a little bit more about how we set up the solution to actually work. If you're not interested in this, skip forward a couple of minutes and you can carry on watching the system function. So let me just start off with a picture of many different variants of clips that we needed to pick up. These are not the actual clips that we used, but I just grabbed a couple of images off the internet. This is more or less what they look like. So I've also included an isometric view of the cell. Basically consists of a couple of elements within it. So the first part is the hopper and dispenser. As you see over here, this is where the operator on the outside will fill the clips into the hopper, and it would be dispensed onto these vibration trays at the bottom over here. The next part of the system is the 6 cameras that are positioned above each of the vibration and picking trays. Then obviously we have a robot and a custom designed gripper to pick up all of the various variations of clip. And then the final part of the system is the final location. This is where the robot would place the clips onto a location tray. So this is a mechanical overview of the system. Zooming in here on the right hand side from a side view, the orange area of interest is where the camera can actually see and the robot in the picking position. You can see the side view of the dispensing mechanisms, etc. So the next thing I wanted to share with you was the brains of the whole system. So this is a solution we call Odin Phantom, and it's basically an AI application that is running that looks at the 6 different cameras and obviously uses AI to determine the position and orientation of the clips. The camera is then connected to the cell controller. So this is the master control of the whole cell. This solution that we're talking about here is obviously a small part of a much bigger automation cell. The cell controller then connects to and talks to the PLC. The PLC then obviously talks to the robot controller. And basically what this AI application does is it looks firstly for presence of clips in the tray. If it doesn't pick up clips in the tray, it obviously activates the dispensing system through the PLC to obviously dispense clips. If there are clips in the tray, but the camera is not able to pick up an orientation, it then tells the system to please vibrate the tray. And it obviously then vibrates the tray until it gets to see a clip that is pickable. The next part of the AI application is obviously look at the part orientation, because as you can see from those clips, we can pick up parts that are either clip facing upwards or even picking up the clip when it lays sideways. So once we've determined the part orientation, we can then determine the XY coordinates of that exact clip that is actually pickable. That information is then passed to the PLC. The cell controller tells the PLC which variant of clip to pick, because there's obviously many variations of clip, but depending on the part being built, you need to pick obviously the right variant. It then obviously passes the orientation and the XY coordinates of the clip, and then obviously the robot program number that is been assigned to pick up that clip from that particular tray. The next thing is obviously the PLC sends the program number to the robot controller. So this is where we would now send the offset locations to the robot, and the robot would then adjust its position to pick up the clip in the right place. So this is just a high-level summary of how the system works. If in future videos you'd like this level of detail, please let me know. Send me a message in the comments and I'd gladly include this kind of detail in future Machine Mondays. Back to the original video.
This is an interesting use case of how AI can change vision systems completely, and in particular robot picking applications. Here's another machine.